everyone, my name is Delaree Johnson, and today I will be presenting my case study on the David and Lucille Packard Foundation headquarters. This building is widely recognized as one of the most successful net zero energy office buildings in the United States. And in this presentation, I will walk through its sustainable design strategies, construction field practices, innovation, features, and opportunities for improvement. I will also connect these topics to specific LEED credits achieved on the project to show how construction management directly influenced the sustainability outcomes. This project is located at 343 2nd Street in Los Altos, California. Completed in 2012, this building is about 51,000 square feet and serves as a corporate headquarters for the Packard Foundation. This makes this site unique. What makes the site unique is it sits on a previously developed land in a downtown area. Redeveloping this previously disturbed site helped minimize the environmental impacts and support community revitalization. The entire facility is designed from the beginning with the goal of achieving a net zero energy, meaning it produces as much energy as it consumes on an annual basis. The success of this project was driven by a highly collaborative team. EHDD Architects served as the lead architect, while DPR Construction managed the building process. Integral Group handled the mechanical, electrical, and plumbing engineering, and the Sherwood Design Engineers led civil work. The Packard Foundation staff and the City of Los Altos were key stakeholders in shaping sustainable design. Although the project was legally structured as a standard design bid build, the team functioned using an integrated design collaboration model. This meant the owner, architects, engineers, and contractor worked together from day one, which made it possible to implement energy and water strategies smoothly. The Packard Foundation headquarters achieved LEED Platinum with a score of 94 out of 110 points possible, as shown in the LEED scorecard on the following slide. This is extremely high for a commercial building under LEED NC 2009. Some strategies that contributed to this score include a 915 panel solar PV array that offset 100% of the annual energy use, chilled beams, radiant systems, and natural ventilation to reduce cooling loads, rainwater harvesting with 20,000 gallons, native landscaping that minimized integration, and most importantly, 95% construction waste diversion. So this is the project LEED scorecard. The project attempted 95 credits, earned 94, and had 0 denied. It's a rare accomplishment that demonstrates exceptional coordination and execution. And then I'm going to go over some highlights from the site visit. From the site visit and research, several insights stood out. One major theme comes from the quote, "Hope isn't something you have, it is something you do." This reflects the foundation's belief that sustainability is continuous practice rather than a one-time achievement. Another highlight is that the ongoing staff-led sustainability task force. Even after moving, the employees continue to promote recycling, commute reduction, and energy-saving habits. The design philosophy, "We sustain what we love," also influenced the architect. Warm materials, biophilic spaces, and abundant daylight create an environment people want to protect. One surprising insight was the team's no new technology mantra, focusing instead on reliable, proven systems such as chilled beams and daylight rather than experimental systems. And then finally, the building achieved a 97% occupant satisfaction rating 1 year post-occupancy, confirming that sustainable design can also support comfort and well-being. So the project sustainability and process and procurement. Sustainability process was strongly supported by the collaboration between the EHDD and DPR. Their joint development of construction documents reduced conflicts and improved coordination for complex systems such as radiant heating and rainwater systems. Material selection emphasized environmental responsibility. 95% of construction debris was recycled. The FSC certified wood and salvage materials reduced embodied carbon, and low VOC materials supported indoor air quality. Procurement strategies also prioritize sustainable vendors with close coordination between the project team and the city of Los Altos. Their $3 million payment in lieu of adding parking allowed funds to benefit the local community instead of increasing hardscape. Challenges included longer lead times for certified materials and extensive verification required for LEED and ILFI compliance. So these are the construction field practices for the project. So construction waste management, the applicable LEED credits include MRC2 construction waste management, which this project got 2 out of the 2 available points. MRC3 material reuse, which got 1 of 1 point, and MRC5 regional materials, which the project got 1 out of 2 points. So for construction waste management program for this project, one of its biggest achievements, the team diverted 95% of all construction waste from landfill, which again helped earn full points for the waste management LEED credits. The salvaged wood that was reused inside the building allowed them to get full points for material reuse. And then the regional materials credit, they only achieved 1 out of the 2 points, meaning that 10% of the materials were sourced within 500 miles. They were close but did not reach the 20% threshold for the second point. Key challenges included the extra labor for processing the salvaged material and the limited supplier flexibility due to the regional sourcing constraints. For storm management and site protection, the applicable LEED credits include SSC 6.1, Stormwater Design Quality Control, SSC 6.2, Stormwater Design Quality Control, and SS 5.1, Site Protection and Restoration, where they received all applicable LEED credits. For the stormwater and site protection, they were able to earn all the points through bioswales, permittable paving, natural or native planting, and restored habitat areas. During construction, strict erosion control and protected staging zones were critical in preserving the site quality. Challenges include complex installation sequencing for rainwater systems and careful maintenance planning to ensure long-term performance. For indoor environment quality, applicable LEED credits include IEQC 3.1 during construction, IEQC 3.2 before occupancy, IEQC 4.1 through 4.4 low emitting materials, IEQC 6.1 controllability of systems, and IEQC 8.1 daylight and views. The environmental quality was strengthened through a detailed IAQ management plan during construction, which earned IEQC 3.1 for lead. However, the team did not achieve the IEQC 3.2, which was before occupancy, which is an important con. The project earned all 4 low emitting material credits because of low VOC paints, adhesives, flooring, and composite woods. They also earned the controllability of systems and daylight and views, with beautiful daylight visible throughout the building. For commissioning and turnover, applicable lead credits include EAP1 fundamental commissioning, EAC 3 enhanced commissioning, EAC 5 measurement and verification, and IDC 1 innovation of design. Commissioning played a major role in the success of this project. They received points for both fundamental commissioning, enhanced commissioning, measurement and verification. They got 3 points, and full points for optimized energy performance, which was 19 out of 19 points. What sets this project apart is its year-long post-occupancy commissioning cycle. By monitoring performance throughout all seasons, the team could fine-tune systems and ensure comfort, leading to that previously mentioned 97% satisfaction score. Challenges included the additional cost that came with extending commissioning and the complexity of the system setting. Here's a summary of some key innovative strategies that the foundation used in the design process. First strategy is the net zero energy performance, that it was supported by that 915 solar panel array and effective systems, which earned the innovation of design credit. Next is the extended commissioning. Commissioning across all 4 seasons again allowed for the team to be able to adjust performance and improve comfort, again earning the innovation credit. The building also integrates beauty and design through the warm materials, natural light, and biophilic elements. This promotes the well-being and supports the IEQ and innovation credits. Finally, the ongoing sustainability task force reinforces energy awareness, recycling, and occupant engagement long after construction. Even with its strong performance, the project still has opportunities for improvement. Some strategies to explore would be smart building analytics to support predictive maintenance, expand gray water or interior non-potable water systems, battery storage to complement the photophilic systems, and continuous IEQ sensors to improve comfort beyond the initial commissioning. These strategies could enhance resilience, long-term performance, and the user experience. In closing, the Packard Foundation headquarters demonstrates how integrated design, strong construction management, and coordinated field practices can achieve exceptional sustainable results. The project diverted 95% of construction waste, implemented effective stormwater management, and delivered high indoor environmental quality and optimized energy use through extended commissioning. These are just some ways to innovate further, but the project stands as a leading example of what sustainable corporate headquarters can look like. And these are the sources referenced or used as a reference throughout this presentation. Thank you for listening.